Hey there, and welcome. Ever wanted to get a peek inside an examiner's playbook? Well, you're in the right place. Today, we're going to crack the code on question 16 from a recent higher tier paper. We're going to break it down piece by piece and see exactly how to lock in every single mark. So, here's the game plan. First, we'll decode the question itself. Then, we'll tackle each part, A, B, and C, one by one. And to finish, we'll master the mark scheme so you know exactly what the examiners are looking for. Let's jump right in. All right, first things first, let's get a handle on the core components of this problem. The building blocks. Okay, so we're given two functions, f of x and g of x. Think of these as our two key players for this entire question. Everything we're about to do for parts A, B, and C is going to revolve around these two little expressions. Okay, let's kick things off with part A. This one's a nice, gentle warm-up, a perfect way to grab an easy first mark and build some momentum. The question is simple. Find f of -3. And the magic word here? Substitution. So, how do we do it? It's pretty straightforward. We take our function, f of x, and literally everywhere you see an x, you're just going to swap it out for a -3. That leaves us with 12 divided by, in brackets, -3 plus 1. And boom, that gives us our answer, -6. Now, in examiner speak, that single correct answer gets you what's called a B1 mark. B marks are basically for the correct answer only. You don't even have to show your work for this one, but, it's always a good habit to get into. Awesome. 1 down, 2 to go. Now, for part B, things get a little more interesting. We're going to combine our two functions now. This is called a composite function, and it's a bit of a two-step challenge. The question wants us to find fg of 1. Now, that notation, fg of 1, can look a bit weird, right? But don't let it fool you. It does not mean f times g. What it really means is you work from the inside out. You apply the function closest to the number first, in this case g, and then you take that answer and plug it into f. So, to keep things simple, let's just tackle this one step at a time. We're going to solve that inside bit, g of 1, first. All right, so to find g of 1, we just grab our g of x function, that's 5 minus 3x, and we slot a 1 in where the x is. That gives us 5 minus 3, which is, of course, 2. Easy enough, right? So for step 2, we take that result, the number 2, and it becomes the new input for our other function, f. So now we just need to figure out f of 2. So f of 2 becomes 12 divided by 2 plus 1, which gives us 4. Okay, let's look at the marks here. You get an M1, a method mark, just for showing you correctly figured out g of 1. That's huge. Then you get the A1, the accuracy mark, for getting that final answer of 4. So you see, the method itself is worth a point. Okay, on to the final part of the question. This last one is all about working backwards. And in the world of functions, that means we're dealing with an inverse. So we need to find g inverse of 4. That little -1 symbol just means inverse. An inverse function basically just undoes the original function. It's like hitting the rewind button. If g of x takes an input and spits out an output, g inverse takes that output and tells you what the original input was. And here's where it gets really cool, and it's a great little insight into how these exams are designed. The mark scheme actually gives you full credit for two completely different, totally valid ways of solving this. Okay, so on the left, you've got method 1, the full-on algebraic way. You find the entire inverse function first by swapping letters and rearranging, and then you plug in the number 4. On the right, though, is method 2, which is way more direct. Think about it. If we want to find g inverse of 4, that just means we're looking for the x that made the original function, g of x, equal to 4 in the first place. So you can just set up the equation 5 minus 3x equals 4 and solve it. And the best part? The mark scheme gives you the M1 method mark for starting down either of these paths. They just want to see that you get the concept. And whichever way you slice it, you end up with this same answer, 1/3. This gets you the final A1 accuracy mark. And you might see OE on the mark scheme, which just stands for or equivalent. So if you wrote it as a decimal, like 0.3 recurring, you'd get the marks for that too. And that's it. We've cracked every part of the question. So let's wrap this up with a final checklist. A quick summary of exactly what the examiner's looking for. This table really lays it all out, doesn't it? For part A, it was just about getting that answer, -6. For part B, the crucial step was showing you worked out g of 1 first. And for part C, that key bit of working was setting the function equal to 4. This is a brilliant little revision tool because it shows you the bare minimum you need to write down to guarantee those marks. Look, if there's one thing you remember from all this, let it be this. Especially for questions worth more than 1 mark, the marks are in the method. Showing your thinking clearly is how you lock in those points. It's not just about pulling the right answer out of a hat. So there you have it. We've taken the question apart, piece by piece, walked through all the steps, and really understood the examiner's playbook. You now have the tools for this type of problem. The only question left is, what will you solve next? Thanks for tuning in.